Hello, everyone. Welcome to the fourth episode of Reactive Land. Okay, today we're gonna talk about flows as usual, but different flows at the same time. So this image kind of represents what we're gonna talk about today. You can look at it from different points of views. Most of them would work, but we just take one of them, and that should give enough image, like mind image, for the concept that we want to play with today. So as you know, it's like we have a flow of water here. It's moving here toward this generator, this turbine. And when it rotates, it creates electricity. And electricity has its own flow. These two flows are not necessarily related to each other. They have their own properties and they're separate flows. So you can see that, like, we want to talk about basically connecting two flows together in a sense. And with that, let's move into the usual comparison that we do between declarative word and imperative word. So imagine that you want to download a music. Downloading a music, it's I/O, so you prefer to not do it on the main thread of your application, on your main execution flow. So if you want to create a new thread in the imperative word, we do like this. We call the download music, which is blocking, and it gives us some bytes, and then we play it, and then we join that thread to the main execution thread so that we don't lose the progress. Okay, if we want to do the same thing in the imperative word, how would that work? In the declarative word, how would that work? So let's say that we have a mono of the name of the music, and then this is flat map, the R is a typo. So, and then we want to download the music. Here, the difference is that this download music is a mono itself because it's I/O. And it's gonna call like a server or somewhere similar to this one. But the difference is that here, this one just returns the bytes. This one returns the bytes inside the mono. Why is that? That's because later in future, we're gonna talk about a reactive HTTP client, and that one always returns mono or something similar. It never returns a blocking type. It returns reactive types. So when we do I/O, when we do call to another server, we usually get a mono, for example, or something that is still a reactive type. So this flat map helps us do that. So far we never put a mono here. We had map here and we had another value here, just the normal data. In terms of our analogies, we would have always put another fish here. Now we are adding another river, another stream. You can say that this is our water flow and this is our electricity flow. Not exactly the same thing, but these are two flows that are not necessarily similar, but they are somehow related. The relation comes from this name in this case. And that's for the flat map. And then we also gonna today talk about do on next. We have so far talked about do on error. We tried do on next, I guess, one time, but we gonna delve into it more deeply today. So these two are the APIs that we're gonna talk about today. And here we are playing the music in the do on next. So what is the flat map, or what is the do on next? So for flat map, in this example, you can see that we have a mono of a number. We flat map it to another mono. So what is happening here? This one is a blocking operation, but it takes some time to happen. It's a I/O operation. We wrap it with a mono. This is not necessarily correct programming, but just for sake of example, it's here so that you know that when you use flat map, you have to have a mono here. You need to have a reactive type here in the lambda return. And that one, so then this mono returns a string. So it's a mono of a string, and our flat map returns a mono of a string. So we can do another flat map later, or we can do a map later. So we can see that the type is here. We don't have a mono of a string in the next one. So it's intelligent enough. It understands that when you use flat map, it flattens this mono to its underlying type, and then you have the type in the next operation, if it's flat map or if it's map. And it's exactly the same here. It's just another example. So basically, you can use flat map in the same way that you use map. The difference is that what you return from flat map is another reactive type. It's another mono in our case so far. Yeah, and you can always, if you want to remember it in some way, memorize it in some way, remember the flat in it, because it flattens the mono, it flattens the reactive type into the type that is inside the mono. So if you have a mono of a string, like here, flat map flattens it to a string. Yeah. So when you have another flow that want to jump, or you want to be attached to your main flow, you do it using flat map. And yeah, that's for flat map. And for do on next, sometimes you want to just do something with the data that is inside your stream, inside your river. You want to just do something with the fish, but you don't want the results of that operation to propagate downstream. So then you use do on next. So let's say we have a mono of x. There are some operations happening here, and at the end you have a x. If you do on next, you will get the x. You can do something with it. This one, do on next, usually is used for sending notifications or logging, for example. So the main thing is that the return type here doesn't affect the stream. And the other thing is that when you have do, that's the semantic here, basically. Whatever happens here, it won't happen in the main execution flow.